Suppose piglet weight at birth is normally distributed with a mean of 2.89 pounds and a standard deviation of 0.32 pounds. Babe weighed 2.11 pounds at birth. Calculate the z-score for Babe. So remember, we can transform any normal distribution into the z distribution or standardized distribution. And that way we can make some assumptions about that distribution. So you don't need to memorize this formula, but to find the z-value of a observation, it's z is equal to x minus the mean over the standard deviation. So Babe weighed 2.1 pounds at birth. How do we find a z-score? Z is equal to 2.11 minus the mean, which is given as 2.89, divided by a standard deviation of 0.32. And that gives us a z-value of negative 2.44. And again, that z-value means that Babe is 2.44 standard deviations below the mean. Okay, question 2 says 40% of piglets weigh less than what weight? Well, again, I like to draw it out. There's the mean of 2.89. I want to know 40% of piglets weigh what amount? And then this would be 40%, right? I want to know this amount. Now I have to use the cumulative standardized normal distribution table to find this z-value that corresponds to this 40%. Now I've given it to you here already. The cumulative standardized normal distribution table indicates a z-value of negative 0.25 for 40%. So this right here is equal to negative 0.25 for the z-value. And I want to know what is the corresponding weight for this z-value. And we can use that original formula, which was z is equal to x minus the mean over the standard deviation. And using a bit of algebra, we can also kind of bring that x out in front. So that'll give us z times the standard deviation plus the mean. So x is equal to, our z-value is negative 0.25 times the standard deviation of 0.32 plus the mean, which is 2.89. And that'll give us 2.81. So the z-value corresponds to 2.81 pounds. So 40% of piglets weigh less than 2.81 pounds. The next question asks, 40% of piglets weigh more than how many pounds? Well, I don't give you the z-value this time, but remember we know that the normal distribution is perfectly symmetrical. So if I want to know this value here, and this is also 40%. And I'm just looking for this value. Because it's symmetrical, we know that this z-value here is just 0.25. And if we have that z-value, then we can plug it into our formula here. X is equal to 0.25 times 0.32 plus 2.89, and that'll give us 2.97. So 40% of piglets weigh more than 2.97 pounds. And the last Babe question, we have Babe Jr. has a z-score of negative 0.5. How much does Babe weigh? Let me get a new canvas here. And again, we can just use that same formula of x is equal to z times the standard deviation plus the mean. So x is equal to, his z-score is negative 0.5, times 0.32, which is the standard deviation, plus 2.89. So x is equal to 2.73 pounds. And I guess I lied about that being the last Babe question. I guess it looks like there's one more. So the last one is, if a z-score of negative 0.5 corresponds to 0.305 on the cumulative standardized normal distribution table, what percent of piggies weigh more than Babe Jr.? Well, let's draw it out. Let me get a new There's our mean. And there's Babe Jr.'s z-score. And we want to know what percent of piggies weigh more than Babe Jr. So what we're interested in is, oops, let's get my green out. What we're interested in is this area here. What is this? Well, I give you the information that a z-score of negative 0.5 corresponds to 0.305 on the cumulative standardized normal distribution table. And that 3085 corresponds to this area right here, right? That cumulative distribution table tells you what that probability is below that z-value. So this right here is equal to 0.3085. Excuse me. But I want to know what this is. So we also know that this entire curve is 1, and so all you have to do is subtract 3.3085 from 1. 1 minus 0.3085 is equal to 0.69115. So now this green corresponds to 0.6915, and we can say that 69.15% of piggies weigh more than Babe Jr.